See, today we are going to have another very tricky important concept which is very difficult to answer by many of the students. That's nothing but p-pi, p-pi bonding and p-pi, d-pi bonding, d-pi, p-pi bonding. So orange, see here children, that's what we are going to do here. If second period elements are present like carbon, nitrogen, oxygen, whatever the second period elements you are taking of the P block elements, then it's always going to form only one kind of bonding, that is going to be p-pi, p-pi bonding. That's only forms p-pi, p-pi bonding. Let us have some examples later. If central atom hybridization is sp, if the central atom hybridization is sp, always forms p-pi, p-pi bonding. So, if central atom hybridization is sp2, first one is p-pi, p-pi and rest are d-pi, p-pi bonds. If the central atom hybridization is sp2, the first one is p-pi, p-pi and rest are going to be d-pi, p-pi. See children, here we have done if second period elements are present, always forms only p-pi, p-pi. But if third period elements forms both p-pi and d-pi bonding, both p-pi and what is say d-pi bonds. Let's have the children. Another one, the rule which you have to remember ever forever is going to be if hybridization of central atom sp3, sp3d, sp3d2, all are going to form d-pi, p-pi bonds. All are going to form d-pi, p-pi bonds. So now we will switch over to examples, guys. First of all, we are taking the second period element nitrite, nitrate, carbonate. See, all are going to form what is C, p-pi, p-pi bonding, because they are going to have only p orbitals in the outermost shell. They don't have p orbitals in the outermost shell. But come to this nana here, its SO4 is going to be sulfate ion. It's going to be phosphate ion. That's nothing but what's called here. What's the hybridization in this case? It's going to be sp3. It's also sp3 children, right? No? Now, Baba, here this is going to be oxidation number is going to be seen here. It's going to be 6. Its oxidation number is going to be maximum plus 5. See the logical concept here. If the oxidation number of the central atom is maximum related with whatever third period element having sp3 hybridization, then they are forming the d-pi, p-pi bonding. Then they are going to form d-pi, p-pi bonding. Why? Because the electrons are going to be excited into higher energy level. Okay children, let's have this. It's also like SO2, sp2 hybridization, SO3, sp2 hybridization. Here it is going to form one p-pi, p-pi bond and another one is p-pi, p-pi bond, because it's going to have 2 pi bonds. And SO3 is concerned, it's going to have one p-pi, p-pi and 2 are going to be d-pi, p-pi bonds here. So that the first one always prefers to form p-pi, p-pi bond and the next one forms d-pi, p-pi bonds. Of course, see this children here, it's going to have sp3 hybridization, sp3 hybridization. This is going to have sp3d hybridization. The central atom is going to be what children? Having sp3 hybridization. What we have learned right from this. If it is having sp3 hybridization, the bonds are going to be, all are going to be d-pi, p-pi bonds. That are going to be d-pi, p-pi bonds. For example, children, let me show you this. Xenon trioxide. Let me show you xenon trioxide. It's having one lone pair. Its oxidation number is going to be plus 6. So that actually 8 electron configuration is going to be s2p6. They are excited to d orbital. That's why they preferably forms d-pi, p-pi bonding. The oxygen contributes only p electrons, whereas this contributes d electrons. That's why it's going to have what's called here d-pi, p-pi bonds only, not p-pi, p-pi bonds here. Let me show you. First of all, we will go through this d-pi, p-pi. Let me check this d-pi, p-pi. Is it right? Let's go through this also here. For example, xenon. Actually, we are having some tricky concept which we have to learn. It's NS2 NP6 Bavaria. Octet configuration. It's going to be here. The excited state is constant. NS2 NP4, what do you call as here? ND2. And next one, NS2, whatever is called here, one more electron has been shifted. NS2 NP6 means the one electron is going to be shifted here. Sorry here, I'm sorry. That's nothing but extremely sorry. NS2, one pair of electrons has been converted as NP5 and D1. The second excited state is going to be what's called here NS2. It's giving us what's called here NP4 and ND2 configuration. Like that we can write the configurations for consent here. So now let's see this figure. What kind of bonds are going to be formed here in the excited state? In the +6 excited state, its configuration is going to be what? It's going to have what's known as here NS2, NP3 and D3. What do you say, children? Is it going to have only this thing? If hybridization is going to be what? sp3, sp3d, all are going to be d-pi, p-pi bondings. So the first p orbitals are going to be form sigma bonds. The first p orbitals form sigma bonds. The next p d electron forms pi bonds. That's why it's going to be all are going to be d-pi, p-pi only. The rest of pi bonds are going to be d-pi, p-pi only. That's the case. Whether it is sp3, sp3d or sp3d2. Okay, got it, children? This is going to be the case. All are, it's going to have what's called here, it's +8, it's going to be having what's known as here. See, this is all forming d-pi, p-pi bonds. The p electrons are going to form sigma bonds. Okay, children, this is what we have done. Very simplest thing, children. If it is going to be what is say here, second period elements, preferably they forms p-pi, p-pi bonds. And third period elements preferably forms p-pi, p-pi and d-pi, p-pi. In certain cases where the maximum oxidation state is there, or else if it is going to have like sp3, sp3d2, sp3d2, the pi bonds are always going to be what is say here, children. It's nothing but what's known as here d-pi, p-pi bonds. Thank you, children. It's such a decent conceptual questions. You should able to answer it, children. That's we are going to do with some examples. I'll give you some example questionnaire that you pretty well know. Like, what are those which we are going to do means? I'll prefer this chlorine oxides. Cl2O7 and whatever is called here Cl2O7 oxide is concerned, and also Cl2O6, and of course dichromate Cr2O7 -2, permanganate MnO4 -1. Find out number of d-pi, p-pi bonds. How do you answer in this case? This is the question for the next session is concerned. Okay? Sure. Thank you, children. Thank you very much.